On behalf of Kriti Prakashan Private Limited, I, Dr. Farzana Shakil Ali, welcome you all to this learning journey with Urja Pedagogy Enhancement Program, an initiative of Kriti Prakashan Private Limited. Good evening, dear educators who have joined today's training program. Kriti Prakashan Private Limited is a publishing company which began its operation in Lucknow in the year 2000. Having firm faith in its motto, that is shaping nations through education, the company has spread its wings of knowledge pan India and abroad during its journey of 21 glorious years. Apart from publishing quality content for children, our vision statement also includes updation of teachers and educationists by empowering them through capacity building programs and trainings twice a year. Our initiative Urja, that is Pedagogy Enhancement Program, focuses on empowering educators in teaching pedagogies in alignment with National Education Policy 2020, Learning Outcomes by NCERT, and Bloom's Taxonomy. We are glad to announce that this year's Urja training program has already started on 15th of July 2021 and it will continue till 7th of August, covering teaching pedagogies of all the subjects of primary and middle level, as well as including early childhood care and education. Today's capacity building program is on pedagogy of teaching physics to middle school students. The study of physics is an adventure. You will find it challenging, sometimes frustrating, occasionally painful, and often richly rewarding, as said by Hugh D. Young. And Albert Einstein said, physics is essentially an intuitive and concrete science. So it's all about studying universe, matter, atoms, and whatnot that universe holds for us. So we have with us Dr. Ritu Bajpayee as a resource person for the day. Dr. Ritu Bajpayee is principal of Mentora Public School, Kalyanpur, Kanpur. She is CBSE resource person, master's and doctorate in physics. She considers educational institutes as nurseries of the future society, since it is in them that children at the most impressionable ages are influenced to maximum. Her vision is to design the future leaders by infusing in them a sense of pride and morale, by nurturing survival skills in them, and by ensuring pursuit of excellence in all fields. We welcome you, Dr. Ritu Bajpayee, to today's session, and we look forward to some enriching thoughts from you. Over to you, Dr. Ritu Bajpayee.
Thank you, Farzana ma'am. I'm so happy that this opportunity is given to me so that I can share with you the pedagogy of teaching physics. As Farzana ma'am already said that Einstein said that physics, but really I would feel that physics is the queen of science, So physics is very important in among all three, chemistry, biology, and physics. I feel like it is queen. Okay, so what we will be learning, like as pedagogy of teaching physics, in this session what we will be learning, we will see what is physics, what is the relevance of studying physics, what are the methods of physics teaching, advantages and disadvantages of each method which is suitable for physics teaching, lesson planning, how to make your lesson plan effective in physics, what are the subject enrichment activities possible in physics subject, and then how will you take the feedback of the student in physics. Then we will see the conclusion. Okay, so this session focuses on the following: learning objectives of physics, what is physics, what are the curricular expectations at upper primary stage, and what are the learning outcomes in science at primary stage, because generally we segregate physics, chemistry and biology in upper primary stage, and till 5th class generally it is being science. Okay, so what is the need of training for the teachers for pedagogy of teaching. Actually, what is pedagogy? Here I would like to clear. Pedagogy is the method and practice of teaching, especially as an academic subject or theoretical concept. What is pedagogy? It is a theory or a group of ideas about how something should be done, made, or thought about. This is paradigm. Okay. Now, there is a change in the instructional paradigm. If I talk about old instruction paradigm, it says an educational institution exists to provide instruction. But now the time changed and there is a new learning paradigm, and what it says, an educational institution exists to produce learning. We do not have to provide instructions only to the students, we have to produce learning, and that is what we will learn in this session today. Why this change in the instructional paradigm has been led? Because if we understand teacher-led pedagogy, then lecturing can be there, note taking can be there, and memorizing the information can be there. If we talk about learner-centered approach, then it shifts the focus of activity from the teacher to the learners. Okay, and it emphasizes what the learners do as against what the teacher does. It is not sure, that whatever the teacher is saying to do, the same the children have to do. Okay, so if based on constructivist theories, we understand learners are not passive recipients only of information. Okay, they're not sitting in the class to receive the information and cannot mold with the information, cannot make changes in the information. So they construct and reconstruct knowledge in order to learn. They can, as it is to receive and to deliver. They are not, for the same. So if I talk about instruction paradigm, most common teaching method, what generally in the traditional teaching is used, and then I'll come to what is physics and how to change the pedagogy and how to make it useful and interactive for the children. Generally, lecture method is followed in the class. Okay, does this method, but you should ask yourself, does this method promote students' learning? Think back about your own learning. How did you learn, when you were a child? What do you remember best? What you have learned in the classroom many years back, What do you remember? Lecturing is economical because it's very economical. Go in the class, say to the students to open the book and start lecturing. It's economical, You will be able to cover large amount of information in a short period of time. This is sure. Okay, but teachers are in the active role and students are in a passive and receptive role. Students are listener, not learners. Most people only remember some part of what they hear, but the longer the lecture, less of the information ended up in the students' notes. Okay. So what do the researchers say? Researchers show that students learn and keep more information when they are actively involved in the learning process. So engagement, this shows what? That they need to be involved. Now learning paradigm, let us understand. It uses student-centered active learning techniques to get students involved in the learning process. It is not only in physics, it is in most of the subjects, it is in all the subjects. But because learning paradigm should focus on the students' needs, abilities, interests, and learning styles. It requires students to be active, responsible participant in the learning process and acknowledges student activities as central to the learning experience for every student. Okay. Now, instead of being teacher-centered, instead of being discipline-centered, what we have to do is we have to be student-centered. And student-centered learning we have to impart in the classrooms. Research shows that student-centered methods lead to increased student engagement with the content, lead to deep learning, long-term retention of knowledge is there, acquisition of critical thinking or creative problem-solving skills is ensured, positive attitude towards the subject being taught, and confidence in knowledge or skills comes. What is student-centered learning? Because in this session, we have to focus on student-centered learning. These activities allow students to apply what they have learned early. Instructional activities should involve students in doing things and thinking about what they are doing. The students has to be engaged in higher order thinking tasks such as analysis, problem solving, synthesis, and evaluation. Students are not just learning in student-centered learning style, but they are allowed to work with and use the information alone or with peers. Their thoughts and perspectives are a necessary input to every class. Students are treated as co-builder in the learning process, not like one-way transaction is not there. This is two-way communication. Okay. So some student-centered teaching methods I would like to discuss. Many of the methods I will be discussing later after showing you lesson plan and many more things. But here I would like to start this session with student-centered, because we all have to be student-centered. Then only we can adopt for the right pedagogy for teaching physics in the classroom. Because student-centered learning does not employ a single teaching method. It emphasizes a variety of methods that shift the role of the instructors from givers of information to facilitators of student learning. We are not givers of information. Okay, we are facilitators of students learning. Teaching methods which are student-centered, all active learning, cooperative learning, inductive teaching and learning, discussion forums, role-playing, and hands-on projects. In active learning, students solve the problems, they answer the questions, they formulate questions to their own, they discuss, they explain, they debate, or brainstorm, during class. In cooperative learning, they work in teams on problems and projects under conditions that assure both positive interdependence and individual accountability. In inductive teaching and learning, students are first presented with challenges, questions or problems, and learn the course material in the context of addressing the challenges. It includes inquiry-based learning, case-based instruction, problem-based learning, project-based learning, discovery learning, and just-in-time teaching. There is a triangle, showing active learning, passive learning. People generally remember learning activities. Okay. But people are able to learning outcomes. 10% of what they read, they remember. 20% of what they hear, they remember. Okay, 30% of what they see. 50% of what they see and hear. 70% of what they say and write. And 90% of what they do. So passive learning has to be changed to active learning, because then only they will be able to define, describe, list, and explain. They will be able to demonstrate, apply, and practice, and they will be able to analyze, define, create, and evaluate. So now if I compare student-centered and teacher-centered instruction paradigms, then teacher-centered, in this case, knowledge is transmitted from teacher to student, and student-centered teaching method or instruction paradigm shows students construct knowledge through gathering and synthesizing information and integrating it with the general skills of inquiry, communication, critical thinking, and problem solving. In teacher-centered instruction paradigms, students passively receive information, but in student-centered, they are actively involved. In teacher-centered method, emphasis is on acquisition of knowledge, but in student-centered, emphasis is on using and communicating knowledge effectively to address emerging issues and problems in real life context. In teacher-centered method, teacher's role is to be primary information source as primary evaluator. But in student-centered, teacher's role is to coach and facilitate. So you have to think whether you would like to be a coach or facilitator, or you would like to only information giver. Okay, because instructor and students evaluate learning together. In teacher-centered method, emphasis is on right answers, But in student-centered method, emphasis is on generating better questions and learning from errors. In teacher-centered method, focus is on a single subject or discipline. But in a student-centered method, approach is compatible with interdisciplinary investigation. Teacher-centered method, culture is competitive, and individualistic. But here in a student-centered method, culture is cooperative, collaborative, and supportive. In teacher-centered method, only students are viewed as learners. But here in student-centered, teacher and students, they learn together. So now you have to finalize, first of all, whether you also would like to learn together by your teaching in student-centered method, or you would like to see your students only as learners, because learning is a lifelong process. So now here I have brought for you changing role of teachers in the current scenario. Old role of teachers, if you will see the teachers, they are disciplinary experts who impart knowledge through lecture. They feel like, whenever they are in the class, they feel like their one eye is on the principal's round. When principal ma'am is coming on round, so I have to see the discipline, because see, apart from student centered, teacher centered, one more method is their discipline centered. They are mostly engaged in maintaining discipline. I do understand discipline should be maintained, but just imagine when all the students in the class will be engaged, they will be more disciplined. There will be no noise. I've seen the classes, where all 40 students, they are engaged, they are making a project, they are engaged in particular activity, and no sound is coming, or they are working happy atmosphere of the class. So instead of making class disciplined, try to make your class happy also. So, but new teachers, they are as designers of learning environments, applying best teaching methods. Old teachers are actors on a stage, but in new role, teachers are coach interacting with the team. In the old role, teachers are delivering a lecture, but in new role, designing and playing a team game. Okay, what is the role of the student in current scenario? Moves from the role of note taker to active participant in the learning process. It is not so that today the child is not present, it's okay. Tomorrow you take the notes from your colleague and jot down and complete your notes. No. Allow students to take control over their learning, and therefore forces them to take more responsibility in the classroom, because there are so many advantages of student-centered learning. And any method you choose, that method, whether you take lecture method, demonstration method, laboratory method, visual laboratory method, and so many methods I will be discussing, but it should be student-centered, because this permits opportunities to connect the content to real life. It provides opportunities for higher order thinking as opposed to passive listening. It promotes greater student-faculty and student-student interaction. It increases student learning. It provides for improvement of social interaction skills, greater acceptance of others, and a greater sense of community in the class. It encourages alternative form of assessment, and it encourages innovation in both teaching and the student involvement. But challenges are there about implementing a student-centered model. Lack of confidence in trying new methods, teachers feel. Fear of loss of content coverage. I will not be able to cover my content in time, and my administrator will scold me. Loss of control over the class, it happens. But once they are involved by hearts, there will be no loss of control over the class. Lack of prepared materials for use in the class. Ego of the administrator or colleagues, lack of background or training in the use of active learning approaches. And that is why this training session will help you to understand these things. Now, why a different approach to physics instruction? Why? Research shows that after conventional instruction, students could not fully explain even the simplest of physics concept, even though many could work-related problems. So worse yet, conventional instruction delivered by talented and even award-winning teachers did not remedy the situation significantly. Let us see one example. Do our students really understand? What does it mean when students can readily solve the quantitative problem at left, yet not answer the conceptual question at right? Let us see. The question is, on the left side, For the circuit above, determine the current in the 4 ohm resistor and the potential difference between P and Q. And here on the right side, the answer is bulb A, B, C are identical. What happens to the brightness of bulb A and B when switch S is closed? They do not know this. How will they calculate, current when resistor is of 4 ohm and potential difference between P and Q is given? If they do not know what will happen when whether the bulb will glow or not if A, B, C are identical. Okay, so this is here what I would like to say after this these many slides, that here we need to understand what should be the right method to teach physics. What has not made a difference in student understanding? Lucid and enthusiastic explanations and examples, dramatic demonstrations, intensive use of technology, textbooks, lot of problem solving and worksheets. Okay, any theory of instruction must answer 2 questions first of all. What should students learn? How should students learn? Okay. Conventional instructions answer is tell the student as much as you can. Most of the teachers are doing the same. And then answer is show the students as much as you can. And teachers are doing. I'm so intelligent. I'm double postgraduate. I'm best in industry. I'm the best teacher, best physics teacher. I have secured 98% marks in masters. But if I cannot understand my child, I'm really not best. Okay. So what is the basic assumption of conventional instruction? Students have the same mental models the instructor does. So to effectively interpret what they hear and see, not warranted by assessment results or interviews with the students. Why does conventional instruction fail? Because it is founded, okay, that it is typically emphasizes plug and chuck techniques to work problems. It is not systematically refined based upon objective feedback. What do students see as important in a traditional classroom? Equations I should know. I should know Newton's first law of motion. I should know the equation that S is equal to ut plus half at square. Similar steps in solving problems. I should know the numerical answers. But I'm here want to ask, where is the physics understanding? How is the modeling classroom? So what you need to do after understanding the pedagogy, now you should understand how to change your class in modeling classroom. So if a student-centered versus, first of all, you have to see it should be student-centered. Students are active or passive. Emphasis is on cognitive skill development versus knowledge transfer. Students construct and evaluate arguments versus finding the right answer. Teacher is Socratic guide versus the main authority. Okay, because let me tell you, physics is coherent as opposed to the view that physics consists of a set of loosely related concepts and problems. Because learning occurs through actively seeking understanding as opposed to the view that learning consists of taking notes, listening to the teacher, memorizing facts and formulas, etc. Okay, so problems rather than models. The problem with problem solving is what? Students come to see problems and their answers as the units of knowledge. Students fail to see common elements in novel problems. So, but we never did a problem like this. So now, rather than problem, make models. So models as basic unit of knowledge, emphasis is placed on identifying the underlying structure of the system. Students identify or create a model and make inferences from the model to produce a solution. A few basic models are used again and again with only minor modifications, like one example. Light chapter of class 6. Okay. Teacher started with what is light? Teacher explained in the class, light is a form of energy that you can see or the form of energy which excites the sensation of vision. Okay. Then definitely this question came in the mind that what are the sources of light? The teacher explained we have 2 types of light sources, natural sources of light and artificial or man-made sources of light. Natural, teacher asked the example from the students and the answer came from the student is sun. Artificial, candle. Then what are the natural? And after discussing with the students, teacher gave, see, never try to impose the definition on the students. Try to get the definition in the language of the child from the students present in the class. It is a more better way of teaching physics. This answer came from the students, that sources of light that can create their own light naturally and are not man-made are called natural source of light. Examples also, do not give examples from yourself. Let the answers come from the students. It may happen that at the place of natural sources of light, they will say candle or tube light or like this, but let the answers come. Okay, then teacher explained in the class artificial or man-made source of light. This definition has also come from the students, that sources of light that cannot create their own light naturally, but they are man-made, are called as artificial. Try to give, miss, why I'm showing this. Try to make simple definition of of the concept of any particular topic or of any particular title. Okay, try to give simplest definition. Okay, now in the same way, teacher defined in the class luminous objects. Objects that emit light on their own are called luminous. Okay, and in the same way, the objects that do not reflect light are known as non-luminous, like moon, metals. Okay, so and teacher will now do the closure of the chapter. The 6 science it was. Today we learned about light, types of sources of light, natural source of light, artificial man-made source, luminous and non-luminous, and then some questions the teacher will be giving for the home assignment. Okay, now a lesson plan I have brought for you. Electric current and its effect. The chapter is of class 7 of science. Implementation time in this lesson plan is mentioned 2 periods. In 2 periods, the theory will be finished. The explanation will be finished. Okay. Keywords of the chapters: battery, electric components, circuit diagram. This definitely children should know. Then only will be understanding the particular chapter. And then children will be learning heating effect of current, magnetic effect of current. So what is the objective of the lesson? Generally, teachers do what? They make the objective for themselves only. I would prefer what? Teachers should share the objective with the students also. Okay, teachers should share with the students that at children at the end of the chapter, you will be able to develop conceptual clarity of the chapter. Actually, what happens, this objective, this lesson plan is basically to get it signed by authorities, by principal ma'am at the end of the week on Saturday before leaving the school, and then for nothing else. Whether that lesson plan is followed in the lesson plan, if you're making, then kindly follow it also. Okay, and you will be able to explain to students that at the end of this chapter you will be able to work in group also for this particular electric current and its effects. Then what are the instructions for the teachers in this chapter? You can do what? You can display a YT video on electric current and its effect, because ICT use is very much effective. Okay, you can do what? You can divide students into 4 groups, 10 students in each group, and you can give them different names, that is A, B, C and D. Okay, then identify one group leader from each group, brainstorm on the video, ask the students to write on the different ways of water contamination and cleaning wastewater. Ask the groups one by one, what are different ways of wastewater treatment? Then instruct the group leaders to make a Google Docs on this. Class 7th I'm talking about. Okay, then some additional information, extensions also you can give. Then class assignment, what you will be giving? Instruct different group members to participate in a quiz on the topic using Google Form or Flipboard. So ask them to complete the assignment at home. Tell them to make a Google Docs for the answers and share it with the different group members. Okay. Now, we have seen one lesson PPT. We have seen one lesson plan. Now I think we have understood that student-centered approach is best in physics teaching. But what is the nature of physics? That also you should know. Physics is a major science, deals with the fundamental constituents of the universe. The forces they exert on one another. Because see, बच्चों को जब तक reason नहीं पता होगा, tell them reason. उनको वजह पता होनी चाहिए. हमें physics पढ़नी क्यों है? If my goal is, they do not know till class 12th. That is why they are facing problem after class 10th. to adopt for the right stream, because they do not know this particular subject why I have to study. मैं पढ़ क्यों रहा हूँ? Why I am studying physics? What is the reason? क्या वजह है पढ़ने की? और जब तक वजह नहीं होगी, you might have noticed the children, those who are in good families, where they are being facilitated with all kind of facilities, they are not doing much. But the students, those who are in adverse conditions, they are doing a lot, because they have wajah, they have reason to do something in the life, because they have not achieved what they wish. But जिनको सब मिल जाता है वो नहीं कर पाते. So at least tell the students to reason for why they have to study physics. So to describe physics as the study of motion, energy, heat, waves, sound, light, electricity, why these chapters are important, Okay, this at least should be clear to the students. Because people today, they are faced with a fast changing world where the most important skills are flexibility, innovation, and creativity. And people can learn flexibility, innovation, and creativity with the subject. So what is physics? As I said in the beginning of the session also, physics is queen of science. It is a part of science that deals with the interaction of matter with energy. So this can be through collisions, motion through electric, magnetic, or gravitational fields, etc. So what is the rationale for offering physics? Physics is not just the study of the natural phenomena, listed above, but it is also a process which has two distinguishable aspects. The first of these is simply the acquisition of knowledge of our physical environment, and the second is, and perhaps more interesting, is the creation of a world view which provides a framework for understanding the significance of this information. Okay, now here if I talk about experiential learning, so the study of physics is generally recognized to be quite old, but there are differences of opinion as to how old, because some would argue that physics began in Western Europe during the Renaissance with the work of Galileo, Kepler, and Newton. Others would trace the beginnings back to the early Greeks and credit Thales with being the world's first physicist. For me, physics is much older, having begun with man himself, because man became a scientist for the sake of his own survival. The very first tool makers were scientists, so they discovered that certain objects in their physical environment were useful for performing certain tasks. Having learned this, they went on to improve on these found objects. So first by what? Selecting objects more suitable for the task involved, and then later actually altering the materials, they found to produce manufactured tools. Now, in experiential learning, I've brought some examples, like how can you teach physics for the daily basis, like, for the practical examples. Like suppose you have to tell the students about heat. Okay, stove. It is, children, you have seen the stove? Heat is energy that transfers from a warmer substance to a colder one. So when you use a stove, the coil, the flame, or cooktop transfers heat energy to the pot or pan that is set on top of it. So then the heat from the pot or pan is transferred to the food inside. So before starting this particular heat, suppose you have to start, give them some more fun examples also, like roasting melty s'mores, over a fire, ironing flat the wrinkles out of shirt, wet clothes are dried with the hot air of dryer. These kind of examples you give them. Okay, like suppose sound. They will relate sound with headphones. Most of the students nowadays, because earlier, when COVID was not there, then we were, as being the administrator, being the principals, we were restricting the students to use mobile, to use Bluetooth, headphone. But now from last 1.5 years, most of the students, they are using headphone, using mobile, because mobile has become one of the mode of to continue their learning process. Okay, so small speakers in your headphones, how can you explain? Use electricity and moving magnets to create sound waves. So the sound waves that come from the speaker bounce of your eardrums, which your brain interprets as music. So sound waves that you hear, whether they come from another person or a speaker, bounce off objects and move through the air and into the ears. So your brain uses the waves to interpret where a sound is coming from. So see how in this way, what you are doing, you are telling children that how physics is in the nature, how the physics is in our surroundings. Okay, other fun examples of sound: a dog barking in the distance, a creaking door on the other side of the room, a tapping a pen on your desk. Okay, like suppose gravity, you have to explain. Gravity, now you will think that what kind of example I can take. Ballpoint pen you can take. At the tip of a ballpoint pen is a ball that rolls as you push down to write on a piece of paper. So there is ink, inside the pen that sits on the top of the ball. So gravity pulls the ink down towards the paper and the ball rolls in the ink as you write. So taking a controlled amount, from inside the pen to the paper surface as it turns. So if you were to remove, the ball that holds back the ink, gravity would pull all the ink down and onto the paper in a puddle. So now they will be excited. Oh, gravity, ballpoint pen. I'm writing with ballpoint pen. So there is gravity working. Other fun examples you can give. You can tell students you can jump over a puddle, but gravity pulls you back down. Lake water is held in the right place by gravity's pull. Football players, they point the ball and gravity pulls it down for the other team to catch. Okay, like the next example is inertia you have to teach. Okay, give the example of seat belt. That when your body is moving, it takes a more powerful force to cause it to stop moving. In your car, your body is moving as quickly as the car is driving. So your seat belt holding you tightly to your seat is the strong force that prevents your body from continuing to move when you hit the brakes. Without the seat belt, a sudden stop can send you out of your seat. They will be excited to know about inertia. Give other examples of inertia. A swing has inertia towards the sky, but gravity is the stronger force that pulls it back to the ground. You throw a bowling ball and the pins are knocked over because they are not strong enough to stop its inertia. A falling tree will squash anything in its way until it hits the ground or a stronger object like a house. Okay, so in this way, now electricity, suppose it is also a major part of physics in 6, 7, 8. You can give the example of batteries. Anything with a battery in it stores electrical energy. The car stores electrical energy in its battery that is used to start the engine and to run the electrical component. Because see, it is very much important to relate the subject what you are teaching in the class with the real life example. क्योंकि जिंदगी जब इम्तिहान लेती है तो subject wise नहीं लेती. We are studying the subjects, but हमें life में कहीं subjects को अलग-अलग use करने की जरूरत नहीं पड़ेगी. Like you people are here. You are like 30 to 35 years old and 40 years old you people are suppose. So कभी आपने देखा after class 12th कभी हमारा इम्तिहान only in the schooling time the examination was been there subject wise. After that life ने कभी क्या आपका exam subject wise लिया है? नहीं लिया. So teach physics in the way and relate it with the real life example, because later on they have to come in the real life and they have to enjoy their life and they have to face the challenging world. So what you can for electricity you can give the example of like engine uses combustion to create electrical energy and that is stored in the battery to be used when it is needed. More fun examples you can add, like a twinkle lights used as decoration pass electricity from an outlet or battery through the wire to light all the little bulbs attached to it. A toaster uses electricity to create heat in the coil. आप कह सकते हैं, you can say to the teachers, students, कि आप अपने घर में देखिए, like what are the objects which are working on electricity and how it is working. An alarm clock needs a constant stream of electricity to show the correct time. When the power goes out, the alarm clock can't do its job. Okay. This is very good example I have brought for you, car crash physics. This activity is a great way to introduce the concept of force and motion. Okay, what are the materials required for this activity? Slow motion videos of car wrecks you can. These video can be found easily, everything. Google से बड़ा आज की डेट में कोई जानकार नहीं है. You can Google it. Okay, so what instructions you can are for this particular activity to conduct. Engage your students by asking them how they think physics might be related to driving cars. Do a think, pair, share with your students and jot down their responses. Then divide your students into pairs and show your class the slow motion videos of car wrecks. In their pairs, ask your students to discuss which areas of the car are taking the majority of the impact. Ask your students to draw a diagram in which they mark the places on the car which are most affected by the force of impact. Then explain to your students that Newton's law deal with the physics of force and motion. Display the 3 laws of the boat. Ask your students to discuss the following question in their pairs. What evidence do you see from Newton's law in the car wrecks? And does anything from the laws surprise you? Why or why not? So as an extension, you could have your students design a car that they think would be able to withstand the impact of crash better than the ones from the videos. Okay, so this is constructivist approach, and what it is. When an individual learns something new, they have to reconcile this with prior understanding. The learner creates a new understanding, either accepting or discarding the new concept. Okay, so there is a big shift now. Passive learning is changed into active learning. Teacher as sage on the stage changed into guide on the side, and abstract knowledge changed into relevant and enduring knowledge. So basic formula has come now for physics teaching. Activity before content. This is the basic formula of teaching physics. What are the guiding principles of constructivism? Because learning is a search for meaning. Therefore, learning must start with the issues around which students are actively trying to construct meaning. Meaning requires understanding wholes as well as parts, and parts must be understood in the context of wholes. So therefore, the learning process focuses on primary concepts, not isolated facts. The purpose of learning is for an individual to construct his or her own meaning, not just memorize the right answers, and just re-regulate, someone else's meaning. It is not learning. So an active physics course, if you would like to proceed in your schools with your students, then you have to focus on making connections between facts and fostering new understanding in students. Use strategies that encourage students to analyze, interpret, and predict information. How you can? The first step is pre-reading, active reading, and then review and problems. Let us see the pre-reading part. First of all, what you have to do, students should be asked to read sections of the text before coming to class. They are expected to take notes and to write out questions on things they do not understand. But remember, highlighting is banned, because generally they do what? They just start highlighting in the book, and this is strictly prohibited. Then take them to active learning. Every class involves some form of practical activity. Activity sheets involve guiding and reflecting questions. Students must be asked to find links between their reading and activity, what they have read in the notebook, book, and then what is the relation between active learning, whatever the activity they are doing. Then what they can do, at least 10 minutes at the end of each class is used in group discussion of the activity. Have their questions from the reading been answered? How does it relate to the text problems? Let us see. Now, we have come to the stage where we should know what are the skills in learning physics, what the students need skills for learning physics. The study of physics actually helps to develop certain abilities and skills in the learners. First skill what the children are receiving, that is communication skills. They involve acquisition of physical language. Then they are developing with social skills. These involve being able to get along with other people, respect for others, and working effectively in groups. Then they are developing mathematical skills. If right physics teaching is taking place in the class, they include computation, graphing, arranging, among others. Then aesthetic skills are also being developed. They involve because artistic sensitivity and the ability to prepare charts, models. This is part of the physics, Safety skills they are being developing, A person keen on scientific processes must be quick to execute correct and timely first aid measures so as to minimize the probable losses due to accidents. Laboratory skills. These are further classified into manipulative skills and process skills as illustrated below and deserve special mention also. So manipulative skills and handling your psychomotor skill, what this is working, handling skills that are well used, lead to accurate results that bring about meaningful, useful conclusion. So processes such as titration, electrolysis, among others, need high level, handling skills. Improvisation of apparatus is an additional skill required. Process skill also they are developing. They assist in investigations or experiments. These are skills needed at every stage or level of an investigation. So for example, if I say observation of color changes during an investigation on effect of heat on substances, so ability to plan good experiments is an important skill that is usually expected of physicists. Okay. What is the aim of teaching physics? I think you have understood now. That is why I have not discussed it in the beginning of the session. Now I think you have understood what is the aim of teaching physics in secondary school. The aim is to acquire a systematic body of physical knowledge and develop an understanding of the concept, principle, application of physics. So in understanding the concepts and principles, then one can further go forward in physics, to develop a scientific attitude by looking at issues systematically and applying systematic methods of analysis, clear steps or procedures. So to develop a range of skills important for scientific investigation and everyday life. This is where the practical papers in school test the skill acquired by the learner. NEP is also focusing, skill development. Okay, so to stimulate curiosity, interest, enjoyment of physics through methods of inquiry and care for the environment, this will definitely help in motivating the students, because it is only a motivated person that spends more time on a subject that achieves more as a result. So in science, the best method of inquiry is the practical approach. Here, like I would like to say, like those who are, opting for science, postgraduate in MSc or BSc, they are having scientific aptitude. So this is a general and common thinking of the people that they are intelligent one, Those in our times also, those who are going, for humanities, so right now we are saying art side or commerce section, they are known as, or they are assumed as less intelligent in the society. So this is because physics definitely, because why? I think you have yourself understood. Because it depends on, curiosity. Then only a child can perform well in physics. So, and what are the instructional objectives should be there for science, for physics teaching? These are written statements of a specific behavior to be exhibited. So in what ways, do you work as a teacher, want this lesson to change your student? Like electricity you have taught, suppose. So what is the objective of lesson teaching, and what changes you would like to see in your students after completion of this particular chapter? Or you should ask you a question that what will they be able to do as a result of the lesson? Okay. So in selecting the lesson objectives, the teacher should keep the following points in the mind. The first point should be the objective may be a concept, skill, attitude, ideal, or appreciation, or any combination of these things. And then objective should be worthwhile learning element related to the course, because one should always have a specific answer for a student who asks, why do we have to study this? मैं बता रही हूँ बार बार आपको वजह होनी चाहिए. Why do we have, suppose why electricity to be studied? This reason you should inform to the students, and the teacher should have each learning product clearly defined in his or her own mind. If suppose the teacher himself or herself is not clear with the concept, with the learning or with the, whatever the learning outcome will be there, then definitely teacher cannot explain the students. Some objectives should be stated in such a way that they allow students to express their own opinions or skills. Some objectives should provide students with an opportunity to explore or create dimensions in their learning. The objectives, must be attainable, but okay, to try to teach something that is too difficult or something that cannot be completed in time allotted is pointless. Okay, so what is effective teaching? Start from phenomena, familiar whether or unfamiliar. So when developing conceptual knowledge, engage with misconception, use a variety of approaches and contexts, Develop procedural knowledge, how to analyze given situation, how to solve problems quantitatively. Practice qualitative and conceptual analysis. Go beyond symbol manipulation, Give students glimpses of the big picture, making connections, simplification, and modeling. Okay. What are the domains of learning? Cognitive. First is conceptual. Recalling facts, analyzing and synthesizing information, applying knowledge. Then affective domain. Next is students take a personal interest in a subject and they learn to express and defend opinions and values. Also self-perception of oneself as a learner. Then physical and behavioral domain. Students gain skills in manipulation and planning. Also learn to work both independently and alongside others in teams. One reflective diary should be there with the teacher. What is the aim? Aim is to help with self-development as a physics teacher. Make a reflective diary for you. Okay. Consider how you might make changes and develop new ways of working. Reflection can mean what? Can mean thinking with a purpose, being critical but not negative, analyzing how effective student learning is, questioning and probing, making judgments and drawing conclusions. Okay. Bloom's taxonomy, always to remember while being in the class and teaching your children. Now, some of the teaching strategies, graphic organizers, visual proofs of prior or new knowledge, predict, observe, explain, POE activities. Okay, some mental models, this is also a technique. Inquiry approach can always be there. Okay, start with puzzling event. Children will inquire when there are explanations to be given. So this is always a good approach. But after the puzzling event, whatever is presented to the children, they may ask the teacher some questions. But every approach has some advantages and disadvantages also. Advantages: children are proactive, they can formulate the hypothesis. In disadvantage, the method is slow, time consuming, not suitable for the children for all age groups. Next is problem solving approach. You can take always. Here what you need to do, you need to provide children an opportunity to solve scientific problems quite independently. Okay. Whenever you want to use this approach to teach a science topic, you will have to start the lesson with a problem. So to test this hypothesis, children are engaged in self-study, mutual discussion, or whatever the practical work is there. Advantages are they learn to propose and structure problem. Students do their own learning. They can formulate the hypothesis, but disadvantages are also there. Again, it is a slow, long, and time-consuming. There is too much emphasis on practical work. Teacher-centered, child-centered, we have already done. But here I would like to show you one study that generally what happens in his classroom, that on average, 95% of the time the teacher speaks and 5% of the time the children are given a chance to speak. Okay, so where the children either are given no opportunity to speak or have a very little opportunity to ask questions or interact, but it should not be there. So this is a definitely, teacher-centered approach is not good. Discipline-centered approach is not good. What is good? Because some innovative teachers, they themselves speak less in class and give opportunity to their children to speak and do more. Because here child is a center of activities. So don't be in 95% of the teachers. Try to be in 5% of teachers. Okay. Method or lecture demonstration method. These innovative teachers involve their children in interaction through question answer sessions. Okay. Demonstration method is always, you know that it is to show. Along with lecture method also you can show any phenomena, any concept or principle. It always provides concrete experiences to the students. Okay, advantages are, there is possibility of using more sophisticated apparatus. Okay, more difficult experiment can be undertaken. More hazardous experiments may be attempted. Okay, disadvantages are always there, like all students do not do the experiments, with their own hands. With the demonstration is complex or there are too many demonstrations. Various details of the apparatus, significant reactions. Other essential steps undertaken by the teacher in drawing conclusions are not necessarily visible to all the students. It may also happen because it happens, whenever teacher goes, on a table, suppose some demonstration is going on. Some smart children, they come near by the table, and those who are shying, those who are not smart enough, they just be at the last and they are not able to enjoy, or they are not able to understand anything. Okay, so laboratory method is always there. Whenever you say to the children, today we will go to the composite lab, yeah, they are happy that they will frame the line, they will push each other, they will they will jump on the stairs, and then they will go to the lab. So this is definitely interesting for them. Always advantages and disadvantages are there of every approach. It promotes learning by doing. It is gives opportunity to handle material by their own hands. It is to learn to follow directions carefully, but disadvantages are also there. Like more expensive as separate equipment is to be provided to each student. It is difficult to schedule actually in the school timetable, as double periods are required. And what is happening when they are coming from lab back? The Hindi teacher is, in the class, and she is, so much annoyed that why the children are coming late, and today I'll not be able to proceed my question answer. And today was the day when I have to complete the question answer, and it is lost. The time is lost. It consumed, until the children came back from the laboratory to the class. Here now, as COVID time is going on right from 1.5 years, and we are having problem in conducting practicals physically in the school. So virtual physics laboratory is also very, very important, because one of the ways technology has benefited K-12 education, in particular in this emergence of virtual labs. Okay, so it serves as a visual aid to teach complex concepts. It ensures the student safety also, that they are not physically touching anything. They engage learners, offer instant feedback, and allows learning flexibility. Cell phone also nowadays, because earlier if I could take this session before a COVID period, then I could never bring this method, but now I have brought this new method, cell phone also as a teaching tool, because cell phones were once considered a distraction in the classroom, but while that still remained true, educators have slowly found that phones can be turned into learning tools. Phones have evolved over the years into powerful teaching aids that, used appropriately, can improve learning outcomes. So use of classroom response system is also there. Like many of the schools, they have taken their own software. Okay, the COVID-19 started, so it gives immediate feedback, make classroom more interactive. Some research-based training strategies are also there. Research-based, the peer instruction process is there. Pose a question, provide a time to think, record your answer, convince your neighbor, revise and record your answer, calculate the results, explain the correct answer. Okay, let us sum up. So there are various approaches and methods of teaching science, like inquiry, problem solving, lecture cum demonstration, laboratory, scientific, project, So each method has its own advantages and disadvantages. So you should be very careful in selecting a method for teaching science. Okay, you should be very clear which method will suit to your class, to your students. It is not so like to the particular school X, if this particular method suits, then to the school Y also this method will suit. And it is not so, because see, everywhere the stuff is different. Okay, the children are coming from different backgrounds. That diversity also you have to. Now if I talk about lesson planning, so at the last of the session I'll show you some good lesson plans of even of my school also I have brought. So nobody understands other than physics teachers why teaching physics is so hard when it works of course. Okay, so physics lessons definitely are complex, and to make a good lesson plan in physics is really a different kind of task. Okay, so here I would like to say that one framework is there. APIBA it is known as, or EPIBA framework is there. This if you will be following, then definitely a good lesson plan you will be able to make. The first is try to engage. Think of engaging your students. Okay, then check prior learning of the children. Introduce the lesson, build the concept, and let them apply. This is the technique. This is the best technique for making your lesson plan. Now suppose, what should be the teaching content for the chapter force and its characteristics? So what is the teaching learning objective in this lesson? To enable students understand the concept of force, to enable students get to the conclusion that force is a push or pull of an object, to explain that forces come into play when objects interact, and then how will you engage? Next, APIBA technique I am just sharing. And how will you engage? To use video presentation to help students get the idea of force, to use worksheets to get the conclusion force is a push or pull of objects. Then how will you explore? Students, by doing group-wise activity, explore that force has both magnitude and direction. Then force comes into play only when objects interact. Then how will you explain? Now you explain. To explain the phenomena of force by concept maps, to explain how various tasks can be classified as push or pull, to explain how forces interact. How will you evaluate? Evaluate students' understanding through previous knowledge based worksheet, questions after demonstration, and recapitulation. And what the teaching support material you will be taking for this particular chapter? Simple animated video of game of football you can take, NCERT textbook for class 8, and pictures you can take from www.google.com. Okay, now lesson plan I have brought for the same for force. First of all, component of the lesson plan, teaching content should be this: force can be used to change the state of motion of an object. The force is applied in one direction, some objects move in the same direction. When force is applied in opposite directions on an object, the next force acting on it is the difference between the two forces. Then learning objective, you have to decide. Then what will be the teaching learning process? Okay, process will be demonstration, group activity. How will you engage? By performing activities. Children will observe, they will recognize the result of forces acting on objects if applied in the same direction or in the opposite direction. They will also observe the state of motion of an object when force is applied. How will they explore? They explore the result of force applied on a heavy body in the same direction or in the opposite direction in their daily life, and also the state of motion of an object when force is applied. Then you will explain the result of force on a heavy body and also the state of motion when force is applied on an object. How will you elaborate? Observe how force results on a heavy object and also the state of motion on an object. Then evaluate. What will happen when equal force is applied on an object? Give them thoughts also. Okay. Teaching learning support material, what you can use in the class? A table you can use, a chair you can use, a rope, a cycle tire, a stick, and a ball. Evaluation through oral questions and worksheet of the mind map. Okay, subject enrichment activities are definitely very important in physics because it is, plenty of opportunities are activities are possible. Ivory soap experiments you can, 10-minute homemade butter in a jar, magic milk color explosion, homemade bubble recipe, making crystals with borax and pipe cleaners. Okay, turning grapes into resins, freezing colors, free chemical reactions, so many, So teachers may also take up, planning of any one of the given tasks. Project work sometimes teachers can have. Crossword puzzles they can have to in order to engage the children. Science exhibitions, whatever projects they are making, throughout the session. It is not so that whenever the exhibition date comes, then 1.5 months you just, engage the students and let the studies hamper. It is not so. Whatever throughout the session they are making the projects and model, exhibit in the science exhibition. Science journals they can make. Teacher may advise students to maintain a science journal. Okay, you may encourage students to write their experiences and ideas on daily basis. It is very good, science journals to make. Creative writing can be there, like tell the students, like tell a story on force, make a poem on force, make a song on the force topic. Okay, so this also can be done. Assessment is definitely very important, is an integral part of instruction as it determines whether or not the goals of education are being met. Okay, goals are met or not, this is fine. This can be understood by the assessment only, because today's students, they need to know not only the basic reading and arithmetic skills, but also skills that will allow them to face a world that is continually changing. Okay, so assessments definitely provides diagnostic feedback, helps educators set standards, evaluate progress, relates to a student progress, and motivate the performance. What you can do for assessments? Weekly quiz you can conduct, MCQ test you can take, group discussions can be there, creating models can be there, doing experiments, monthly test, wrap-up questions after topic can be there. Quick feedback, always give students, otherwise they will be like you take the test on Saturday, and after, and you say to the children that I'll show you the copy on next Saturday, 3 Saturdays are passed, but you could not show the copy. No, it should not be there. Quick feedback you have to provide, and positive feedback, because it is very much needed to build their confidence and improves their positive self-talk. Motivation is a vital factor in the teacher's management of learning and behavior in the classroom, because motivation signifies the causes or why of behavior. It is concerned with questions of the energizing of behavior and the direction given to the behavior. Okay, so the motivating role of teachers encompasses attempts to create conditions within a classroom which will energize, direct, and sustain students' performance. It is very much important. Okay, and at the last of the session, I have again brought one lesson plan of class 7, wastewater story. Okay, objective of the lesson is what? At the end of the chapter, students will be able to develop conceptual clarity of the chapter, origin of wastewater, constituents of wastewater, cleaning of wastewater. They will be able to do work in group, okay, and important aspects they will understand. So what the teacher will do, you can display a YT video on wastewater, then you can divide students into 4 groups, 10 students in each group, identify the group leader, okay, brainstorm on the video, ask the students to write on the different ways of water, ask the groups one by one what are different ways of wastewater treatment. Then additional information you can give. Okay, class assignment, instruct different groups member to participate in a quiz on topic on Google form. Okay, like then rubric checklist to assess individual students using Google Sheet, assessment for learning at the last you can have. Okay, then after conducting the quiz, must make a checklist also. Okay, like did the group was able to develop the, because this is for you, this is your assessment, your teaching, your teaching happened well in class or not. So was the group able to answer, was the group able to complete the given task, all group member participated in the task given or not. Okay, so this is for you. Like force and pressure we have already seen. So here one more like force concept. Okay, like this is the same lesson plan, learning objective and outcomes. This is one lesson plan I've brought for you. See, always for the teachers, uh, resources are available. TeachersofIndia.org, cbseshiksha.com, cbseacademic.nic.in, ncrt.nic.in, schools of educators. You can always take the help of these resources online available for the teachers. Okay. So I've come to the conclusion now. Classrooms must provide a suitable environment for interaction between students and teachers so that meaningful learning can take place. It is of utmost importance to recognize and value each learner and his or her diverse intelligence to provide an opportunity to bloom. And there are various methods which can be used during teaching learning process to sustain the inquisitiveness and interest among students, which may also help in recognizing the abilities of the learners. And teachers may think over their teaching practices, analyzing how concepts were taught and how the practices can be improved or changed for achieving better learning outcomes. Thank you for listening me, and I hope that this session will be fruitful for you and you will be adopting these methods of teaching physics in your classroom. And hope that you enjoyed the session. Physics, always remember, it is the queen of science. Understanding physics can be a great experience for the students. Thank you.
Thank you so much, Dr. Ritu Bajpai. Digi Nurture and Kriti Prakashan both extend their gratitude to you for sparing your time and sharing such valuable insights for the subject. I loved the passion. I loved your passion for the subject. That was truly reflecting from your voice and the way you have presented the whole thing. So, thank you
Thank
so
you.
much and happy learning to all of us. Thank you so much.